Hi, I want to take a few moments to go over an idea that there isn't very many videos online about, and that is using a systems of linear equations to find the equation of a line in slope-intercept form. So we know that slope-intercept form is y equals mx plus b. All right, so here's my example. I'm going to do two of them here. So my example is I have a line and I know the point 10, 92 is on that line, as well as the point -11, -55. And I want to find the equation of the line that passes through those points in slope-intercept form. So what we're going to do is we're going to set up a system of equations by taking 10, 92, -11, -55, and plugging those in individually into slope-intercept form for x or y. So when I plug the first point into the slope-intercept form, I get 92 equals 10m plus b. And then when I do the same thing with the second point, I get -55 equals -11m plus b. Now this is a system because you got the m's and the b's. Well, m is slope and b is the y-intercept. So since there's only one line that goes through these 2 points at any given time, m and b must be the same value. So this is a system, and I can leverage that. So we're going to solve the system for m by using elimination, by subtracting the b's away from each other because they're both the same. And so let's go through and see what that equals. Okay, feel free to use a calculator. So we got 92 minus -55, that is 147. That should equal 10 minus -11, which is 21m. And the b's cancel. And so to find m, or the slope, I'm going to take 147, divide that by 21. And what I get is m is 7. So the slope of the line that goes through these 2 points is 7. Now to find b, since I'm using a system, I'll take the 7 for m and I'll insert it into one of the equations I wrote to solve for b. So I usually use the first equation. So just plug 7 in for m there, and let's see what we get. So we get 10 times 7 is 70. And then we're going to subtract the 70 away, which is 22. So I have an m and a b, and so the equation to my line is 7x plus 22. Okay, this method is awesome because it allows me to not have to use that slope formula, which I see in my role as a math teacher, constantly done incorrectly. So let's try another one. So let's go to a new next slide here. So let's try another one of these. Okay, so okay, so now the point, here's example 2. So now the point is on the line I want to find are 49, -81, and -21 and 9. So we're going to do the same exact thing here. So we're going to first set up my system. So the first point, plugging that in, is be -81 equals 49m plus b. Then the second one is going to give me 9 equals -21m plus b. And again, we're going to subtract the equations, essentially using elimination to eliminate the b's and to solve for m, or the slope. So -81 minus 9 is -90. equals 49 minus negative 21 is 70. And the b's cancel. So we'll divide both sides by 70 to get m solve for. So we get m is going to equal negative 90 over 70, but we always reduce fractions, especially with slopes. So I get negative 9/7. So we'll plug that in to one of my equations. So I'll do the first equation. And then we'll solve. So we'll go 49 times negative 9/7, and that's going to give me negative 63. Then we're going to add the 63 to negative 81, and I get negative 18. So I got my m, I got my b, so y is going to equal negative 9/7 x minus 18. So this is a neat way of using a system of equations, to find the equation of a line in slope-intercept form. So I would try to replicate this for a problem you're going to do and see if it works. All right, thanks for your time.